Alright, so welcome back to the dojo. Alright, this module we will be talking about graphics and animation and the fundamentals of that topic. Alright, so this module is going to introduce you to the visual graphics and animation technologies that are available in modern standards compliant web browsers. Alright, and the reason we're going to learn about that is because we want to learn and find out how we've already learned how we can manipulate the HTML and the DOM, etc. And pretty much we've been relegated to static features, inserting elements, removing elements, etc. But now we're going to talk about how we can take the full-fledged graphics technologies and use these in order to draw lines, polygons, other shapes, and fill them with colors and manipulate 3D dimensional graphics and objects, etc. So before we do that, we need to talk about some of the common concepts and techniques that all graphics and animation subsystems have available in them, all right? So we're just going to discuss a couple terms in this lecture. And we won't go too far into it, but we'll learn a little bit here. All right, so first of all, we need to know that all computer graphics operations are generally performed within the context of a coordinate space. Ooh, sounds really cool, doesn't it? Coordinate space. All right, well, basically, what that means is that we have coordinate space is really a 2D or 3D region, and you should be familiar with 2D or three-dimensional means, right? 2D is like a flat shape that we see drawn. 3D is like a three-dimensional shape that has some depth to it. All right. So how do we coordinate space is a 2D or 3D region within which colors, lines, shapes, or other entities are placed. All right. Well, how do we represent these 2D or 3D regions? Well, we represent them with what we call coordinates, hence the term coordinate space. All right. We use a coordinate, one coordinate for each, or one value for each dimensional. So in 2D, you would see something that you're probably familiar with from grade school, which is XY coordinates, right? So you'd have an X value for the X value along the X line, and a Y value for the value along the Y line, so our width and our height, right? Then we'd have, for 3D regions, we'd have three coordinates, X, Y, and Z. And Z represents our depth, all right? And you'll probably see two common coordinates, 0, 0, and 0, 0, 0, which are what we call the origin, all right, or the 0, 0, 0 central location, okay? All right, and generally you can just sum all that up to say that coordinate spaces define where and how big the objects or the images that we manipulate are. All right, and here's just an example of a 2D and a 3D object. So we see our 2D on the left, which is just a flat square, and our 3D object on the right has some depth, makes it look like we actually can see the box, which we can rotate and do cool things with. We can probably stick Pokemon Go in there somewhere. All right, so the next topic we need to talk about are colors. All right, and you should be very familiar with how the colors work from your HTML class. But basically, colors form the basis of what an entity looks like. All right, and generally we represent color with an ordered tuple. All right, an ordered tuple is just a list of three values. All right, and for color it's usually RGB, which represents red, green, and blue. So you'll usually see values such as 000, which represents black, 111, which represents white, red, which represents 100, which represents red. So can you guess what green would be? 010. All right. Generally, we refer to it as a color cube that represents the range of what colors can be represented. So you could see this cube and you see different colors on each side of the cube, and we can choose locations in the cube to represent a particular color. So if you think about what we just talked about, the cube will be represented with an XYZ value, right? Hence our RGB value, which is three values. All right? And sometimes you'll see a fourth value, which is called the alpha channel. And what that represents is the transparency. All right? And it's generally a value minimum value of 0 and a maximum value of 1. And the 0 represents is fully transparent, right? And 1 would mean it's completely opaque. All right. Now, the values for RGB are sometimes represented different systems represent them different ways. But two common ways you'll see it are a value between 0 and 255, or you can see it represented as a hexadecimal value, such as that's spell hexadecimal. No, hexadecimal. All right, and hexadecimal would generally be something like pound FFF, right? Or like pound 00FF00 for white. All right, pixels versus object vectors. All right, so we will generally see our images, or two different approaches to graphical images, or scenes as we call them. All right, pixels or objects, which we sometimes refer to as vectors. All right, so pixels are generally represented as a grid of colored squares, right? And you see this a lot with the images produced by a digital camera or a scanner. All right, and objects or object space perspective, also known as, you'll see more commonly called vector-based graphics, are a way of or viewing our images as a collection of entities. And we should know entities from our discussions of object-oriented programming in other classes, but a collection of entities that we can then manipulate individually. All right. Now, the pixel approach means that we can manipulate the pixels directly, right? I can change the color of every pixel in my image because it's made up of pixels. In the object approach, I generally use properties to manipulate that object. So properties such as size, location, color, line style, we manipulate that object by manipulating those properties, okay? And that controls the overall appearance of the object itself. All right, so between the two, we don't really have a best approach, but in programming, it's all about trade-offs and understanding what trade-offs each approach gives you. All right, so because we're working with each pixel directly, the pixel-based approach gives us really fine-based control over the image that we're trying to manipulate, or the scene that we're trying to manipulate, down to every single dot in the picture. All right, but with the object-based approach, we don't have that fine-based control. However, we use fewer resources. And what are resources when we talk about computers? Right, memory. All right, because we're instead of using millions of pictures, we're now talking about objects. All right. And finally, animation. And basically, animation is taking a sequence of images and showing them to the user fast enough that it looks like the picture is moving. So if you remember back when we were young, we would draw pictures in, well, I'm still young, we would draw individual pictures in like a little pad, and then we flip through the pad to make the arm move or something like that. So it's the same concept, all right? So if we take a pixel-based approach to animation, we will be redrawing the entire image every time. However, if we were taking a vector-based approach, we would be manipulating the object properties in small amounts at each frame, or what we call an interval. And we'll get more into that as we progress. Take care.